Hello friends, this is Soumya, Assistant Professor, Department of Mathematics, Government Pursuit College, Tumkur. So in this session, we shall have a brief recap of differentiability. So the recap of the differentiability functions. In the previous classes, we have discussed about the limit of a function and the continuity of a function. So we shall see now the definition of the differentiability. Derivative of a function at a point. We shall see now. So differentiability means we say it as the derivative of a function at a point. So let y equal to f of x be a function, then the derivative of f of x at x is equal to a is defined as limit as x tends to a f of x minus f of a divided by x minus a, if it exists, is called the derivative of f of x at x equal to a. So we define the differentiability as the derivative of a function at a point. So for that we consider a function y is equal to f of x, then the derivative of f of x at x equal to is defined as the limit of f of x minus f of a divided by x minus a as x tends to a, if it exists, is called the derivative of f of x at x equal to a. The derivative of f of x at x is equal to is also denoted by f dash of a, which is equal to limit as x tends to a f of x minus f of a divided by x minus a. And now we shall see the differentiability of right hand and left hand derivatives. So we know that f dash of x is defined as limit h tends to 0 f of x plus h minus f of x divided by h. So the right hand derivative of f of x at x is equal to a is defined as right hand derivative r of f dash of a equal to limit h tends to 0 f of a plus h minus f of a divided by h, provided this limit exists. So similarly, the left hand limit is defined as L of f dash of a. So left hand limit of f dash of a equal to limit as h tends to 0 f of a minus h minus f of a divided by minus h is called the left hand derivative of f of x at x is equal to a. So the difference is that, so here we have taken a plus h because it is the right hand limit, it goes on increasing, and f of a minus h for the left hand limit. So and also h in the denominator for right hand limit and minus h in the denominator of the left hand limit. So right hand limit means f dash of a equal to limit of h tends to 0 f of a plus h minus f of a divided by h, and the left hand limit is defined as L of f dash of a equal to limit h tends to 0 f of a minus h minus f of a divided by minus h. So we shall see a note on this. A function f of x is said to be differentiable at x is equal to a if both the right hand limit and the left hand limit of the derivative of x is equal to a must be equal. So that is r of f dash of a is equal to L of f dash of a. Now we shall see the problem. So verify that f of x is equal to 1 plus x for x less than or equal to 2 and 5 minus x for x greater than 2 is differentiable at x is equal to 2. So we have to verify that the given function is differentiable at x is equal to 2. So differentiable means we have to prove that both the right hand limit and left hand limit are equal. So for that we shall consider f of x is equal to 5 minus x. We shall consider f of x is equal to 5 minus x. So f of a plus h equal to f of 2 plus h, because a is equal to 2. X is given, x is greater than 2, so we shall consider a is equal to 2. So f of a plus h is equal to f of 2 plus h, and f of 2 plus h is 5 minus of 2 plus h. So 5 minus 2 minus h, 5 minus 2 minus h, which is equal to 3 minus h. So f of a is equal to f of 2, so which is equal to 5 minus 2 equal to 3. So right hand limit of f dash of a equal to limit h tends to 0 f of a minus h minus f of a divided by h. So which is equal to limit h tends to 0 3 minus h minus 3 divided by h, which is equal to limit of h divided by minus h as h tends to 0 equal to minus 1. Then to find the left hand limit, so f of x is equal to 1 plus x, so f of a is equal to f of 2 minus h, which is equal to 1 plus 2 minus h equal to 3 minus h. So f of a equal to f of 2 equal to 1 plus 2. So we have got it as 3. So left hand limit of f dash of a is defined as the limit of f of a minus h minus f of a divided by minus h as h tends to 0 equal to limit of 3 minus h minus a divided by minus h as h tends to 0, that is equal to 1. Therefore, right hand limit of f dash of a is not equal to left hand limit of f dash of a. Hence, the function is not differentiable at x is equal to 2. In the next problem, examine the differentiability of the given function f of x is equal to x square sine 1 by x when x is not equal to 0, and the function is 0 when x is equal to 0 at x equal to 0. So to find the right hand limit, the solutions to find the right hand limit, so let f of x is equal to x square into sine 1 by x. So f of a plus h equal to, because e is equal to 0, so f of 0 plus h, which is f of h, is defined as h square sine 1 by h. Therefore, f of h is equal to f of 0 equal to 0. Therefore, right hand limit of f dash of e, that is limit as h tends to 0, f of a minus h minus f of a divided by h equal to limit as h tends to 0, h square sine 1 by h minus 0 divided by h equal to limit h tends to 0, h of sine 1 by h equal to 0. Therefore, right hand limit of f dash of a is 0. And to find the left hand limit, f of x equal to x square sine 1 by x. So f of a minus h is equal to f of 0 minus h equal to f of minus h, and it is defined as h square sine of 1 by minus h, and which is equal to minus of h square sine 1 by h, because sine of minus theta is minus sine theta, so minus of h square sine 1 by h. So f of a equal to 0. Therefore, left hand limit of f dash of e, which is defined as limit of f of a minus h minus f of a divided by minus h equal to limit as h tends to 0, so minus h square sine 1 by h minus 0 divided by minus h, and which is equal to limit of h into sine 1 by h, and it is equal to 0. Therefore, right hand limit of f dash of a, which we have got it as 0, and it is equal to the left hand limit of f dash of e, which is also equal to 0. Hence, the function f of x is differentiable at x equal to 0. And the theorem for your reference, so if f is differentiable at a point, then it is a continuous at that point, you can prove this theorem. And the example for your exercise, so consider a function f of x is equal to minus x for x less than 0, and it is equal to x for x greater than or equal to 0. You have to prove that it is continuous but not differentiable at x equal to 2.